Good afternoon. Those who are on time and watching me live, thank you so much. Welcome. And those who are watching the recording, I would suggest that you skip the first minute or so because I will wait for some more children to join. Those who have joined, I will quickly go through, say, within the first 1 minute or so. Uh, in case someone is watching this video recording directly and hasn't seen the previous classes, I will take up as many doubts as I can. This course is NCERT based and all questions in NCERT will be discussed, and today we are going to discuss all the questions which are related to electric field, and we will see all those we will be doing in the class today. If you want to discuss further, you can join my physics telegram group, the details of which have been given in the first 2 pages of the course that we are following. This is the course and this is how you can join. Go to anytimeteacher.com. In the top there is a menu, academic courses for MCS. Find 12th physics and there find electrostatics. And click on take this course next to the green colored free. There are self-assessing quizzes on each page which you can try right there, that how much do you understand the content on that page. These are the ways to reach out to me. These are mentioned in the first 2 pages of the course. Harmoin Wisely. Hello bit. So, and this is the link to the simulations that we are going to use, and today we are going to use it quite a lot. Rather, today's class is based on the use of these simulations. If you are following me, Anhat Khurana, Shashank Jha, Harmoin Weasley, must be Wesley, sorry, and Banshaj Raj Bhardwaj, all welcome. Kindly follow today's class carefully because all questions which are asked related to finding Adit, Anisha, good morning, good afternoon. All the questions which are asked, whether in CBSE or elsewhere related to finding net electric field, we will be doing them today and we will be solving all the NCERT questions also. Welcome, Juanita. So, a region around a charge. And how do we get charge? How do we get charged bodies? Yesterday in the class, we saw that. You can see the video prior to this one. I have numbered these videos in such a way that you do not find a difficulty in following them. So like today's class is 1.3, electrostatics 1.3. So if you see it in 1.2, we had a charged object and we have seen, Gauri Priya, welcome. We have seen how do we get a charged object. So in the books, what is mentioned as Abhinav, I'm wishing you all in the beginning, but after a while I will stop responding to your good afternoons. I hope you don't mind it. So, when in the books it is written, a charged rod is brought near to a conducting shell, what does it mean in our day-to-day vocabulary? What does it mean in our day-to-day vocabulary? The charged rod we saw, these straws which we use to drink juice or cold drink, these were our charged rods. We could have had better things also, but then what I mean to say is such a humble, simple thing acts like a charged rod, and they are very, very easily available. Very easily available. And what were we rubbing it with? We were rubbing it with these tissue papers. Good afternoon, Sir Devanshu. Your voice is quite faint. Is that adjustable? I will speak little louder, but then sometimes Devanshu, here Joshi, welcome. When I speak loud, people say the voice is echoing or it is jarring. So I'm trying to speak little low. But if it is all right now, do let me know. Now I have increased my volume little bit. I'm speaking little louder. But in case you don't understand, I will repeat it. It doesn't matter. though it is getting recorded, it doesn't matter. I will repeat. So charged rod that we talked about is this simple straw, and we are not rubbing it with silk cloth, though I do have access to silk cloth also. Our synthetic shirts work equally well. So if you are putting on a synthetic shirt, you can say rub it off like this, holding it between your the fold of your elbow and rub it off like this. Okay, volume is all right. Devanshu, kindly check your own connection, because Harmoin says that the volume is all right. Okay then, so this is the charge rod. This is what we are rubbing it with, because these are the simplest available things. And when we said conducting shell, conducting sphere, conducting body, I had these things. I'll show it to you once again, little bit closer. What are these? This is the table tennis ball, and because I was having only one table tennis ball, this is another light ball which is part of the toys that my son plays with. Light ball, plastic ball, and so I have borrowed it from him, and I have wrapped these balls in that foil that we get, this foil. I have wrapped it up in this kind of foil, simple foil that we use in the kitchen to pack rotis. That is what is acting like a conducting shell. And when we brought it near, we had induction. Uh, we also say we join them together, and then we separate them out before taking the rod away, or we separate them out after taking the rod away. That affects and results in getting either a charged shell or not getting a charged shell. Likewise, if you are having just one single shell and you bring a rod near to it, then you can earth that shell. You can earth that shell. And whether you remove the earthing, uh, after removing the rod, or you remove the earthing before removing the rod, it results either you get a charged shell or you don't get a charged shell. We have done these activities in the previous class. So the reason that two charged bodies, say might be two balloons, you charge them by rubbing on your head, and they repel each other. This is also an activity that we have done in the class. So we were trying to see what is the cause of these kind of phenomena, and I requested you to start thinking in terms of what would have gone in the minds of our ancestors, of our forefathers, when they saw these kind of phenomena. And we have gone through that part, that they could conclude there are two types of charges, and they call them plus and minus, positive and negative, because when put together they were cancelling out each other. So they put it in positive, negative, and later on when electron was discovered, it came out, it happened to fall in the category of those which were labeled as negative. Okay, Devanshu, good to hear that. So a charge has around it a field, an area of influence. Like a mass has around it a field which you can call it is the area of influence, the region of influence. A charge has one kind of field around it, and we call it electric field. A mass has another kind of field around it, which we call gravitational field. Likewise, anything which is magnetic in nature has around it a magnetic field. Now, it is a matter of development of this topic that later on people started realizing that what they are calling as magnetic is related to what we were calling as electric, and if it changes with the time, then these two are correlated. And there is a theory which is called Grand Unified Theory, GUT. It says that all fields are related to each other in one way or the other. That is not part of our class. That is not part of this lecture. Right now what we are saying is a charge has around it a region of influence, an electric field, and anything which has a similar nature means if there is another charge and it is kept in its neighborhood, then that charge will experience a force. There will be some sort of interaction between the two. If something has mass but does not have a charge, and you place that thing in the neighborhood of this charge, then they are not going to experience electric force. So easy way to remember, say if their nature matches, something electric in nature and another thing which has a similar nature means must have an electric nature, only then they will have electric force. Something having mass means gravitational nature, kept near to another thing which has a gravitational nature means another thing having mass, kept near to each other, they will experience gravitational force. Uh, Likewise, you can talk about magnetism also. Now, as the distance increases, this effect decreases. Remember that dialogue from Sholay says 50-50 कोस दूर जब कोई बच्चा रोता है तो माँ क्या कहती है, बेटा सो जा, गब्बर आ जाएगा. Now ask that gabbar. Anshika says, sir, your voice now isn't clear. Anshika, will you please check at your end, because others are finding it okay. I will try to increase little bit my voice little bit. If I increase it too much, it starts becoming jarring. Kindly check, because during these days the bandwidth is not too much, but I have kept this. Ansh Vashisht, welcome. So going back to that dialogue from Sholay, ask that gabbar that what does the mother says when a child who is 200 kos dur, he cries. If a child 200 kos dur cries, what does the mother says? What will gabbar say? Not ki beta. Ansh also says low voice. Acha, so I will speak louder. I will get little bit away and I will speak little louder. I hope it becomes better. So, region of your influence, it reduces as you go away. What is no, sir? Sir, please mute notification. It's very loud. Notifications are muted. The oh, huh, the laptop is muted. I think now I have muted. Okay, thank you for your live feedbacks. Is it all right now? So now let's understand that field once again. Let's understand that field. What is happening in that field? There is one person who says, जहां जहां से मैं निकलता हूं दुकानें बंद होती चली जाती हैं. Ask that person कि जब आप चले जाते हो तो दुकानों का क्या होता है? He will say दुकानें फिर खुल जाती हैं. So it means your asar, your influence is restricted to few shops which are nearby, which are in your sight. Yes? So you are a chota gabbar. See what does the big gabbar says? 50 kos dur. But even with that gabbar, if you ask 200 kos dur, what happens? The gabbar's effect is also gone. So there are two factors. One is how big, what is your personality? And in case of electrostatics, we say how big is the charge. If the charge is more, the effect is more. And if the charge is less, the effect is less. But for a fixed value of charge, as you go away, your effect will keep on decreasing, keep on decreasing. Now let us see this thing in these simulations. It is quite normal, but sometimes I wake up in the middle of the night thinking about the transience of life and how we all just are slowly being dragged towards the cold. And I don't know what you are writing. Man himself added, concentrate on this work. So what we'll do now is we will go to that simulations and we will see these cases there. Few things I have already placed. And we will answer some questions from CBSE. We'll see some questions from CBSE and also from NCERT. So first thing, let's place, and let me remove this minus also. I was playing with it already. So there is a positive charge, and if you want to see its area of influence, the region around it, you can move it around and you will see wherever you place it, there are arrows going out. There are arrows moving out. So a positive charge has a region of influence around it. And we have seen it qualitatively using that example of Gabbar and Pachaskos and that Gunda, Chota Gabbar, who goes into. We have seen that example. But if we place a sensor, that sensor will give you an impression, visual impression. And remember this thing, because we are going to use this thing to solve those questions in NCERT or those questions which have been asked by CBSE. So this is a crucial, even though I'm getting you into stories, but what we are talking about is a serious business. So this sensor is giving you the bigger the arrow, larger is the magnitude, and you can see those values there. Right now, do you see 21.8? We will talk about the unit later on, 21.8, and now you see 2.57. Then you get it close, 20, 36, 47, 51. Do you see 60? The field increases as you get nearer, and you see the size of the arrow is increasing. So size of arrow is giving you a visual impression of the magnitude, and the direction of the arrow is giving you the direction of the electric field. So two questions. Remember and keep a record how many questions we have done today in the class. Plot the electric field of a Q when Q is greater than 0. It is given on your screen. But then this answer is not complete because it is a tool to learn. What is there on your screen is a tool to learn. It is not an exact answer. And so let me write something to explain what is that fine thing which was asked. Um, just a second. Okay, so what was asked? There were two questions. Say, plot electric field due to Q when Q is greater than 0. Now the same question could have been asked like this. What it means? So this one means it is a positive charge. This one means it is a negative charge. And you have got an idea that if you put a positive charge, the field is away. The field is away like this. That's what I have shown you. This is what I have shown you here. And if it is a minus charge, then the field is towards. Now the problem comes. What if this Q is on a small metallic shell? What if this Q is not a point charge? Point charge is a point. And you can't touch a point. Right? If you touch a point, R becomes 0. It will be infinite, undefined kind of thing. What if this is a, say, this is, I'll draw it here. What if this plus Q is on a small metallic shell? Do I draw the field lines like this or should I draw the field lines like this? Now, 1 year, CBSE asked this question and touching and not touching, half mark was deducted. So listen to this thing very carefully. If it is a shell, if it is a metallic shell, the field on the surface can be defined. We will see it very soon. but outside it will be outside, radially out, but on the surface it will be defined, so you have to touch it. So let me change the color. This kind of line, if metal shell or any shell, I should not even put a metal. If it is a shell, metal doesn't matter. If it is a shell, you have to touch it. But this kind of line, if Q is a point charge, Q is a point charge. So we need to see the mathematics behind it, that why is it that we are doing it like this. Now, that we have see that what we saw here, that as the distance increases, electric field decreases. Decreases as what? 1 by r is a decrease. 1 by r square is a decrease. 1 by r cube is a decrease. 1 by r raised to power 4 is a decrease. So decrease as what? I want to put it as a question to you. How would have our forefathers concluded that electric field due to a charge decreases and decreases with 1 by r square? See, there are certain cases, and we will come to that while we are doing this course. Field does decrease even as 1 by r. There are cases in which the field does not decrease. As you go away, the field does not decrease. There are cases, and we will be doing that case. And there are cases in which the field decreases but as 1 by r. And there are cases when the field decreases as 1 by r square. And there are cases in which the field decreases as 1 by r cube. So how do you know that the field decreases as 1 by r square and not as 1 by r, and not as 1 by r cube, and not as 1 r raised by 3 by 2 or any other number? I want you to think the way our forefathers would have thought. Do not say it is written in the books. Even if it is written in the books, I will find out and verify, or somewhere at least I will convince myself that the answer is 1 by r square and not 1 by r cube or not 1 by r. Now, how will I answer? I am giving you the hint so that if you are someone who is genuinely interested in learning, you can go ahead and you can find out, you can learn, you can do whatever you want to do. There is a topic called Gauss theorem, and Gauss theorem allows you to find electric field due to various symmetrical cases. It makes life very, very easy. I will be answering it from there, that the answer is 1 by r square and not anything else in case of a point charge. But right now, for a point charge, I will restrict myself to what I can convince you, I can show you at least, that as you go away, E decreases. As you come nearer, E increases. For a positive charge, E is out. And for a negative charge, I'll remove this positive. The field is towards. Do you see this? Towards, wherever you say, it is towards. You come closer, it increases. You go away, the field decreases. So I will restrict myself to what I can show you. It decreases. And after that, if I'm saying 1 by r square, that field decreases as 1 by r square, that is something that I have not answered yet. But in due course of time, I will answer this question also. So for today, I am starting with one thing, that due to a point charge, Dhruv Srivastava, sir, we test the field at different distances and see what gradient it makes. 1 by r square will have sharper gradient than 1 by r. Dhruv, that's an intelligent answer. That's an intelligent answer. You can even present it like this, that you get these values and you put it in a, and you see which variation does it satisfies. But then that is like holding the hand like this thing. This simulation has come from those values. So it is actually holding the ear with a, but then at least you have some feeling, you have some sense that yes, it is happening like this. Okay, means good, appreciable answer. Now, questions which have been asked in CBSE and also in NCERT, and we will be doing it today. What if there are two charges? And two charges can be both positive, they can be both negative, it can be one positive, one negative. And I am giving you a glimpse of an important topic coming ahead. One positive, one negative equal in magnitude. So plus q and minus q equal in magnitude, placed at a little distance apart. This is called a dipole. Plus q and minus q. It could have been plus q1 and minus q2. Means not only the signs are opposite, but the magnitude is also different. But if it is plus q and minus q, plus q and minus q, magnitude is same, sign is opposite, then in that case it is called a dipole. So I do not want you to mug up and go to page 25 of NCERT and draw all those diagrams. I want you to get a first hand feel that the field is like this. Two questions which are very important, whether you say CBSE and in NCERT it has been asked many places. CBSE has asked it innumerable number of times. Draw the field due to this combination, say plus q1 plus q2 minus q1 minus q2 plus q1 minus q2, or plus q and minus q, which is a very important topic. So what we will do is we will get a feel first, ki what happens, and then we will see whether we add, we subtract, or we find vector resultant. We will see that. Okay. So to begin with, I am putting 1 plus q, and I want to find out the field somewhere here. Okay. So I will put the here. You can't even see the arrow. Do you see the arrow up away? Or okay, I'll put it here where you can see the arrow. But if you can't see the arrow, there is another way to do it. You increase the charge. Remember that? Now I increase the charge more. This is plus 1 nanocoulomb in one go. So now it is plus 3 nanocoulomb. Now do you see, as the Q increases, this increases. Now how do I know that in the formula for point charge, it is Q in the numerator and not Q square or not Q cube? You look at the size of this arrow, whatever it was, if it becomes double, and then when I put 3, it becomes 3 times, then it has power 1. See, some ways that we can convince ourselves. So I say this is Q, I'll remove 1. This is plus 2 nanocoulomb here, and the field due to this plus 2 at this point is towards right. And how much is the value? 2.9. Now I am putting another plus 2q, say plus 1 and one more plus 1. So I have plus 2 nanocoulomb here and plus 2 nanocoulomb here, and I want to find out what is the net field here. Now you can see it visually that whether do you have to add it or you have to subtract it, you can see that. When I place 1, what happens? When I place another one, what happens? Do I add? Do I subtract? Or if you want to be even more convinced, then I remove this and you see the field only due to this. So you see what is the direction of the field? To the right. And when I place only this one, that is towards the right. So if I say when both of them are placed, say plus 2 here, plus 2 here, then will you add? How will you find the resultant electric field? By adding or by subtracting? You can see it visually. Okay. Now in this one grid is of 0.5 meters. One grid. So right now they are placed 1 meter apart. All these mathematics is possible. And if you want to find out, few quantities are there that you can find out. This one we haven't done so far, so I don't want to go with it, but then you can get some values here. You know, at different points it will give you different values. There are a lot of things that you can do. Another thing that you have is this thing. If you want to find out the distance from here to here, even there are these means that these inch tape kind of thing is there. You pull it and it tells you how far away is this charge from here. All these kind of things are possible in this simulation. Now let me move on to the second case where we have plus 2 and plus 2 and we want to find out the field in this part, in this part. Same method. What I'll do is, just to make it simpler, I will make it 1 nanocoulomb and 1 nanocoulomb, and one at a time, one at a time. So when I place 1 nanocoulomb here, the field at this point is towards the right. If I place 1 nanocoulomb here, the field is to the left. Now remember this thing. If I place 1 nanocoulomb here at this point, I'm not moving the sensor now. The field at this point is towards the right. But if I place 1 nanocoulomb here, the field at this point, I have not moved the sensor, is towards the left. So when I place both of them, I place 1 nanocoulomb here, 1 nanocoulomb here, what is going to happen to this field? What is going to happen to this field when I do it like this? You have to add or you have to subtract. That is very easy to visualize. You can make it out that in this line, it is subtracting. And one of the proof is, if I put it exactly at the center, you see the field becomes 0. Here the field becomes 0. Here the field becomes 0. Now, one important question that is asked. There is a plus q kept here, plus q kept here on this line. See, this line is called the axial line. Axial line. This line. A-X-I-A-L. Axial line. This line is called equatorial line. And you are asked, how much is the field when they say somewhere here? And what is the direction? So let's do it once again. Let's try to visualize it once again. Plus 1 nanocoulomb kept here. The field at this point is like this direction. Do you see? Something like northeast. But if I place this charge here, then the field is to something like northeast. And if I place plus q at both the points, what might have happened? Let me find a way out to handle this situation. Just a second. So what might have happened? That because of this plus charge, there would have been a field in this direction. We saw it, just now we saw it. Due to this plus charge, there would have been a field in this direction. Now this one will have two components. Okay, this x component and this y component. Likewise, this one will have an x component and it will have a y component. Now this one and this one, they cancel out. They cancel out each other. And these two components, they add up. These two, they add up. And so the net electric field is in that direction, which you see in this simulation. Likewise, if you move this point down, will it increase or will it decrease? Now that comes a very, sir, how did we come to know that the electric field of a positive charge is away from the charge? That is convention. Vector resultant, okay. Side cancels but upward adds together, okay. So you people were listening. And now all of a sudden your comments have started coming. Because for a long time I saw Dhruv Srivasta's comment was a last one and now you have started. Adit, what is positive and what is negative is convention. But then because you place the sensor we talked about in class 1, the sensor is what? A slight small positive, what we call as positive. Out of that group, we have taken a light thing. And because that experience is a force away, so what we are saying is that the field due to this charge must be flowing out. So that's how we have set up the convention. That what we call as positive, its field must be going out. You can remember it like this. Way of remembering. Positive-minded people, they give. Negative-minded people want to hadap jao sab kuch, grab, give me, that kind of thing. So, but it's all convention. Two things which are positive, they repel each other. Two things which are negative, they also repel each other. And very easily, say very much possible that we could have decided what is positive, what is negative, could have been the other way around also. Shrey says electric field directions is perpendicular to velocity. Electric field direction is perpendicular. So if we map it, we will get field. I'm not able to understand. Shrey, electric field direction is perpendicular to velocity. Whose velocity? So if we map it, we will get. You mean to say potential? But we haven't talked about potential, Shrey. Potential will come in second chapter. This is right now chapter 1 going on. So we will have field, we will have force. That's all. Potential and capacitance will come in second chapter of electrostatics. And these two chapters together are 10% of your CBSE syllabus. Okay. Now, what I want to say something very crucially important. Something very, very interesting. As it comes closer, as this thing comes closer, what do you expect the magnitude to be? Now, this is where this fun lies. What I'll do is I'll remove everything so that you don't get a precursor kind of information. And I'll remove the sensor. And this time I will put a positive somewhere there and another positive somewhere here. So along y-axis, I'm putting two positives. And I am putting the sensor somewhere here. Now, what do you expect? If I bring this sensor closer, what do you expect the magnitude to be? The direction will be in this side along x-axis that we have seen, because due to this charge, the electric field is in this direction. Due to this charge, electric field is in this direction. These components, they cancel out. So net electric field is towards x. That we have seen. That we have seen. How much it is, we will calculate also. But that we have seen. But as it comes nearer, what do you expect the magnitude to be? Direction, I agree. Direction, I agree. Okay, great. Some says decrease, Shrey says increase first, then decrease. Magnitude will decrease. Shashank Jha. Okay, everybody having, good afternoon, Ronnie. Have a guess? Okay, so what I'll do is I'll show you, without talking about it, I'll show you. As it goes away, it decreases, and I was expecting that. As you go away, ultimately it will become zero also. If I take it to infinity, it will become zero. As you come closer, it increases, expected, but then keep watching the size of the arrow, the size of the arrow, the size of the arrow, and in between it becomes zero. What happened? Due to this plus, remember that field is away at this point, yellow wala point. Due to this plus, the field is away, means upward, and they have cancelled out each other because this point is at the center and both of them are 1 plus 1 plus 1 nanocoulomb. So it is 0 at infinity, it is 0 here, and somewhere it has become maximum. Aryan Singh, this question relates to your math. What we will do is, we will find out right now how much is this E, and then you will use your maxima minima and find out and message me that answer. At what point does it become maximum? At what point does it become maximum? These two plus plus, and on this point, so what I'll do is I'll go back to and I'll add one page. And there is a little bit you will learn, and then there is a lot of homework for you. So there is a plus q kept here, and there is just a minute, something that it is giving. I pressed a wrong button. Just a second. Oh, technology sometimes really troubles you. Okay, okay. So I'm back to normal, and I'll draw this and I'll leave this question to you. Plus q and plus q. And let's take this distance for some reason that I'll be using later on, 2a. So this is a, this point is O. And from here, x away, I'm having some point, say some point P. So due to this, the electric field, I'm calling it E1. Both are, let's call it E naught, because both of them will be equal in magnitude. This is also E naught. And if I say this is theta, this will also be theta. So these are also theta, theta. So you have E naught cos theta, E naught cos theta, 2 E naught cos theta this side. And this side, you call it EY component, which is basically E naught sine theta. Same thing is this, E naught sine theta. And these two, they cancel out each other. So my net E at P, if this point is P, this point, let me call it, this point is P. My net field at P is 2E naught cos theta. Okay. Now I am using the standard result of E, which I gave you qualitatively. 1 upon R square is there, Q is there, and that constant of proportionality is 1 upon 4 pi epsilon naught. Q, we have taken this as just Q upon this distance. Now, if this is X, this is A, this distance is A square plus X square. So when you say R square, this becomes A square plus X square under root and square, R square, into cos theta. Now cos theta in this diagram, cos theta, X upon this thing. So X upon A square plus X square under root. Now if you sort it out little bit, 1 upon 4 pi epsilon naught, this Q also I am putting it here. This is X upon A square plus X square. This was under root whole square. Under root whole square, and this is 1 by 2. So this is whole thing is 3 by 2. So you have X in the numerator and you have X in the denominator also. You have to tell me where is EP maximum. I know one thing. I know one thing. At O, EP is 0. At infinity, EP is 0. This is common sense. I have even seen it. We placed the sensor here and we saw it is becoming 0. Remember that? So what is that value of X? Where is this maximum? I am asking what is that value of X? This is a question from math, maxima minima. Now I'm moving back to that scenario and I'm going to put say 1 plus and 1 minus. What I'll do is I'll put 1 plus first. I'll remove everything else. This thing I'll remove. And say I check here 2 boxes away. What is the direction of field? It is towards the right because from a positive charge it is away. Now I am removing this positive charge and I am placing a negative charge here. The direction of electric field very much expected. It is towards the negative charge and it is towards the negative charge, it is down. If I put that plus and this minus together, remember if I put a plus here, the field is towards the right. And if I put a negative charge here, the field is towards the down. So right and down should create a field somewhere here. Somewhere here. Let me put it here. It is so. It is so. The way they will ask you question is, they will put this negative here, and then they will say, plot the electric field, show, draw the field A upon root 2. Adit Singh, have you done it right now or have you seen the answer? If you have done it right now, very good. I really appreciate it. But then the question they will ask you, and I told you this is a very important topic, plus Q and minus Q, it's a very important topic. They will say, draw this electric field and tell the value at a point here, which is called an axial point. At a point here, this is not a very important question, but then you must do it. At a point somewhere here, that what is it? Yeah, A upon root 2, I agree. Adit, answer is correct. Answer is correct. Hermoine. Number one, I don't know your exact name. But then, have you also got the same answer? Because you are saying yes, Adit. Have you got the same answer? Or do you know the answer? That is calculation part. Okay. And third question is that they will ask you is find out the field here. The direction. Done it. Okay, good. Very good. Very good. Extremely good. What is the direction of the field here? They will ask you to draw it and how much is the value. Now to find out the value at this point, you have to, let me go back again to the ways that I was adopting. Very good, Harmoin, very good. So at this point, say you want to find out the field here. Due to this positive charge, the field is in this direction. And due to this negative charge, the field is in this direction, towards. Same thing. If you take the components, of this one and this one, you will find this side, these two get added. Very good, very nice. I think you have put the photograph because you want to show the working. Very nice. These two will cancel out each other, whereas these two will get added up. And so your net field is supposed to be in this direction. Likewise, work it out for this point, which is called an axial point. Work it out for this point, which is the axial point. I will show you the results and suggest that you play around with this system, with this simulation, because it will give you a very good clarity of thoughts. So what I'll do is I'll move my, say, this sensor here on this line. No, before moving it, let me ask you to guess. This negative, because of this negative, the field is towards. And because of this positive, the field is away, to the right. What do you expect the field to be when both of them are kept here? What do you expect it to be? Because this negative is closer, so this negative field due to this minus q will dominate. Likewise here, the field will be always towards the right because due to this positive it is away, due to the negative it is towards right. So you will get the answer by subtracting it. But then because the positive charge is nearer, this will dominate and the field will always be out, always be to the left. Now what do you expect the field to be here? Due to positive, the field is towards right. Due to negative, the field is towards right. And so I expect the field to be right, 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 right. But then do you see, visually I am getting a very odd kind of effect. Do you see that? Do you see that? These kind of things demand some mathematics to be done. If you are a medical student, I won't suggest you to do all this thing. You don't need it. But if you are an engineering student, I suggest that you do these calculations. Last question for today. And remember, this plus q and minus q is a very particular case which is called the dipole, electric dipole. Now, in this case, plus and minus, if I move it on this line, which is called an equatorial line, then at every point I see that the field is towards right. At every point I see that the field is towards right. But then do you see another thing? The size of the arrow. Size of the arrow. Can you mathematically convince me that yes, as you move away field is going to only decrease, because remember what happened earlier. I will repeat that what happened earlier. What happened earlier was this, that as you moved, field increased and then again decreased. Did you see that? The field increased and then again decreased. Did you see that? But then when I put a plus and a minus, all of a sudden the situation is like this. Can you convince me mathematically that what I'm seeing is the right thing? There is no error. So we have seen few cases. You will find we have covered actually all NCERT questions. We have actually covered all NCERT questions. But then I will take another class to finish off the calculations and talk about those numbers. This class is 3.3. I'll call that class 3.3b, so that or through the Telegram group, we will match the answers. The assignment for this thing will be posted in the course. Try and solve those questions. I will add it up as the self-assessing quiz. I'll add it up there. Tomorrow is Sunday. Tomorrow there won't be any class. So I will find a time. I will be having time to set up a assignment for you, a kind of practice paper for you. Thank you so much for being in the class. See you on Monday now. On Monday. Thank you. Yes, Monday 12:30 p.m. Thank you and bye-bye.